Hi, thank you. While I was preparing the presentation, the topic a bit changed and expanded. This is my first talk ever, so I am a bit nervous and excited to be here to talk to you. So, manage states. Do you need to manage state? Yes. Probably you should. Except maybe if you are building some kind of a pure application that have some inputs and gives you the same outputs. Well, I'd like to present you the solution which we at Flocktory developed, which you can think of as a black box. So it would be easy to understand for beginners and advanced programmers. So how do you manage state? We need to first understand what state is. So we have these things like identity, state, and values. Identity is an entity which can have different values or states at different periods, points of time. So state is a set of values. And value, as we know, are immutable things. So we can think of identity have different immutable states. And the app have states too. And we think of states in apps regarding resources or APIs, like database connection is a state. When we have opened the connection, when we closed the connection, it's a different state. If we have a service, we would like to query or do some stuff, it is also a kind of a state. So what exactly do we manage? Besides database, we also manage cache. We can have in-memory cache, we can have memcache, we can have consumers of Kafka or different queues. Also, we have in-memory aggregates. We would like also to manage them. And also, because of this part of these states are resources, they are kind of a dependencies. So, if our application has to query a database, I hope that we have an open connection to a database before we run a query. So we need to be sure that the dependencies are loaded. So when we do poor job at managing dependencies, we can have not loaded dependencies, not loaded connections, don't have cache, whatever. And if we try to maybe manage it not in a systematic way, then it could be hard to maintain it, hard to change the code. So I hope after I've said until then, it's pretty obvious why we need to manage it. So minimize the error, low dependencies, and use economic use of resources. So if our service have different namespaces, places to query a database, we would like to have a single connection to a database, not every time when we query it. And we would like to think of managing states as a pattern or a template. So it would be, you can avoid writing a boilerplate, you can copy paste it, deal with it, and it's also a pattern of dependency injection and sometimes inversion of control. But somehow, while I was preparing this talk, I realized that solution to managing states also became a solution to another, because as a developer at Flocktory, I don't have a pain of managing states. I don't know this problem because I use the solution and it's solved automatically, and I solve another problems. And this is what I call rapid application development. And what do I mean by that? Not that software factories, Metamodeling, DSLs, and some academic stuff. More like having parts of an application, because writing an app nowadays is more like having parts, combining parts, and writing some business logic as high level in abstraction as we could. So here enter dev component. It's a macro built on top of Stuart Sierra's component. I'd like to present you not like bottom-up approach when we build this dev component, but more likely as a black box solution. Like, how do you develop it? With it an app. And I'd like to present the structure of the dev component, which we use, as I said, to gather resources, and we don't model domains. So this is like the simplest representation. Dev component, it has a name of the component. It has a dependency, like it depends on database. It also have config data, which is available inside this component. It's what we do. We can define a function that starts a component and says what should happen when it starts, and also when it stops. And so if we would look at DB component, it would be something like that. We make a connection, and then we return a component. And when we stop it, we destroy a connection. And as you can see, this DB is a dependency injection. I'd like to look at a contrived example, but it's kind of example that we use at production. So let's see, we want to make some worker. We split worker into two components because we would like to debug a component without starting a worker, a cycle in REPL. So we can load component, but don't start the worker. And we can see that some component don't have start or stop functions. And as I use the red color, so you could pay attention that we would use a sync function to do some work. And when we define the function sync, it accepts one parameter component. And inside we use it as a map. So we have access to dependencies as just values of some keys like DB. Okay, as I said, it's a rapid application development as I see it, because we just said this is component, this is a dependency, this is what should happen, this is boilerplate. If we would do a worker in Flocktory, we just copy paste this code and then write our stuff here. Like, we just concentrate on writing the business logic. And we have a lot of components in our repos, like DBs, cache, services. So we just combine those parts. And for example, we wrote a worker, and we noticed that after some time there was a significant load in the database, and we decided, well, we need to use cache now. And it's pretty easy now to modify this component at cache. We just say that now it also have dependency cache, and we rewrite a bit of logic in sync we use the old query_db function, and voila. So the next question would be, okay, we defined our components, our parts, but how does app work? What should we do with them? Okay, so how do we start a worker? Enter system. We have system which we define like app, we sometimes use metrics, and we start a system. So a system is a combination of parts. And this, we also use at Flocktory, a so-called reload pattern from Stuart even before him, so we could, in REPL, if we have changed the code, we can reload it, a system, restart the system, and test it, which is done usually by this code. Also I'd like to show the example of inversion of control with an example of Kafka consumer. Also, there is a bit of code here, where we define our dependencies, and you can notice that in the middle of it is inject to. So we have like a consumer component, and we have a component called Kafka system. So if we would like to test how our consumer works without consuming messages, records from Kafka, we can start just a consumer component. We have some functions, and also it can be extended and use different protocols and implemented. This is the same definition of component. As you can see, with red color, we implement protocol, iRecord consumer, and we use a function consume record, where we put our component as this and the record, and it could do stuff. So the question is, why not Stuart's component? Well, because when we define system in Stuart's way, we have to define all the dependencies while we're defining the system. So it's not so much as combining parts, building blocks, and building different blocks from these blocks. We need to go all the way down while defining the system. With dev component approach, you can use this block you built and just put it in the system. And you can define dependencies inside this box. Other pros is we use this approach to aggregate some metrics. So we just add it as a dependency, and inside of processing functions, it's pretty easy to build metrics. And last but not least, tests. Yeah, sometimes it's hard to write tests. It's a necessary thing, and writing in kind of functional language, maybe just testing functions. Unit testing is not enough. So it would be a good way to have an kind of end-to-end or integration testing. And to do that, usually you'd have, if you have Kafka, databases, services, you have to spin up the whole system. Maybe load the local Kafka, databases, memcache, etc. But you can have like redefs, and we have like a solution. We can mock components, which is we have consumers components, we have database components, cache components, call to APIs. We can mock them. Don't use redefs. And for example, we have this high-level component called engine. It's a rules engine, and it's built from parts and realizes some functionality. And as you can see, we don't have in dependencies databases cache because it's inside of those components. And we would like to test our engine, our rules engine. How do we mock the test? I won't show you the whole test because it would be hard to read and comprehend, but I think the most illuminating part is when we use fixtures, we can, when we mock APIs, we can service client mocked something where we could use functions which accept some arguments, or they could return something constantly. And we have, for Kafka, event patterns. So we can define in Eden what kind of events, as the result of our code, should be produced in Kafka. So we can then match if our application have produced to Kafka as we expected. Also, we can, well, when we use DBs, we use Postgres. It's easier to run Postgres locally than to try to mock all the SQL queries. But all the other services we mock. So I'd say that in dev component you should trust. And if you have any questions.
I suppose we haven't got any questions yet, though after this presentation, after the second one, we will have some time for networking. And during this time, you can ask any speaker whatever question you want. Oh, you have a question?
Yeah.
Yeah?
Did you compare it with Integrand?
Well, Ivan Gushaev has a book, it's written in Russian, and it compares integrand, mount, and components approach. So if someone interested in comparing them, I'd recommend to read it.
Yeah, not just if you have an opinion, like it's like more so as I understand it's more dynamic compared to component.
Well, we've written dev component.
Just your dev component is more dynamic than.
Well, it's been written a few years ago, so the situation was different, and we won't go like rewrite in integrand or rewrite in all the Clojure code in Go or whatever.